Okay guys, now I'm going to talk about arithmetic series. Now with series, it's a bit different to sequence because sequence is just a list of numbers that are in an arithmetic form, but series is when we add the numbers, okay? So when we have all the terms added together like that, okay? So see how there's all the plus signs in between, okay? So when it's still got to be arithmetic. All the numbers must be arithmetic, okay? Must be going increasing or decreasing in the same number, but it must be adding up, all right? So therefore, if something like this is an arithmetic series, then guys, the important thing here is the sum, okay? See how it's addition? That means we have to know the sum of those series, okay? So I'm going to show you the sum formula, and again, yes, this is something you have to memorize. I'm sorry, but this is a little bit similar to the sequence one, so hopefully it's not too difficult to remember. This basically, the sum formula is this: n divided by 2, the big bracket, okay, and then inside that we have 2a plus n minus 1d, okay? So basically, inside this bracket here, we have 2a plus n minus 1d. Remember the sequence formula was a plus n minus 1d? Yeah? But with the series formula, we have 2a plus n minus 1d. So make sure it's 2a, not just a, okay, for the sum. And then for the whole thing, we multiply n divided by 2. Okay? That's the only difference. That's the sum formula. Okay, yes, please memorize this, but hopefully you get used to it as we go through the questions, okay? So don't worry too much. But as you can see, it's a little bit similar to the sequence one, isn't it? Okay, so trying to find a way to memorize it. Now, this is the sum formula, but also there's another sum formula, and this one is when we know the first term and last term. So if you're given the first term and last term, instead of using this big formula here, just use this one, okay? So this one is same as this one where we have n divided by 2. So we have n divided by 2 here, and we also have n divided by 2 here. But inside, we simply have first term A plus last term L. It's represented by L for last term, okay? So A plus L, first term plus last term, and then multiply to n divided by 2. Okay, and that's basically all there is to this kind of formula. So yes, you have to memorize both formulas. Both are for sum, both will get you to the right answer, okay, or the same answer. Alright, trying to remember both. And of course, first term is A, common difference is D, and L is the last term. Okay, so hopefully this is not too bad. This one is a little bit easier to memorize, isn't it? But this one, I'll read it again for you, okay? It's n divided by 2 times 2a plus n minus 1d. Okay, that's the sum formula for an arithmetic series. Okay, let's go on to some questions. Hopefully this will get you a better understanding. So starting with question 9. Find the sum of 20 terms of an arithmetic series if the first term is 9 and the last term is 99. Okay guys, hope some of you can tell me that this is going to be easy because they tell us the first term, they tell us the last term. What did I say guys? If we know the first term and last term, we simply use the formula n divided by 2 times first number plus last number. So a plus L times n divided by 2. So we know that A is going to be 9, the first term is 9, the last term is given that it's 99, and how many terms? So n represents how many terms there is, right? How many terms are there? They say find the sum of 20 terms, so we're going to have n as 20. Alright? And simply put it into our n divided by 2 times first number plus last number formula, like this. So n is 20, so we have 20 divided by 2 times first number 9 plus last number 99. Okay, that's pretty simple, yeah? And then just simplify it, guys, okay? That comes to 1080, okay? 20 divided by 2 is 10, okay? Times it by 9 plus 99, you should get 1080, okay? That's the sum of 20 terms, yeah? So adding all the 20 terms there is in the arithmetic series, okay, the sum will simply be that. Okay, so guys, all I used was that particular formula there, n divided by 2 times a plus L. Okay, so try to remember that. That's question 9, so hopefully you think that is pretty simple as well. Okay, let's move on. Question 10 says, Part A, it says find the sum of the first n numbers of the series 1 plus 3 plus 5 plus 7, etc. Okay, it says find the sum of the first n numbers. So we're going to probably have it in terms of n. So what I'm going to do is use my formula for the sum, n divided by 2, 2a plus n minus 1, d. That's the formula, right? Now we can't use the first number and last number formula because we don't know what the last number is, okay? So we're simply going to use our usual sum formula, that one. Okay? Now, n divided by 2, we're going to have it in terms of n, so leave n as it is. Now a is the first term, which is going to be the first one on the list, which is simply 1. So I'm going to put a as 1, so we have 2 times 1. Okay? And then we have n minus 1. D is the common difference. What are we adding by, what's the difference between 1 and 3? 2. What's the difference between 3 and 5? 2. And the difference between 5 and 7? 2. So therefore the common difference is simply 2, so that's why I put that there. Okay? And then simplify it, like this. So Sn just becomes n squared. Basically guys, look at this, n divided by 2 times, look, this is just 2, right? Okay, so we have 2 plus 2 times n, we have 2n, 2 times negative 1, so negative 2, and see how the 2 cancels? So we're left with n divided by 2 times this, which is 2n. 2's and 2 cancels, so all we're left with n times n, which is n squared. Okay, so therefore Sn, or the sum of n terms, is simply given by the rule n squared. Okay, so you can think of this as like a little general term or a general equation of the sum. Okay, so depending on what n is, okay, it's going to be n squared. So we've got that. Now on to B. It says find the sum of the first 50 odd numbers. Odd numbers, see how this series is 1, 3, 5, 7, these are odd numbers, isn't it? But they want you to find the sum of the first 50 odd numbers. This is our sum formula that we've got in question 10a. So to find the sum of the first 50 odd numbers, all we need to do is, well, first of all, this is the S50 where it goes 1 plus 3 plus 5 plus 7 plus blah, 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 plus the 50th term. Okay, 50th term is the last term, isn't it? Right? So therefore, all you need to do is just sub 50 into this formula here. So I have 50 squared, which is simply 2500 or 2500, sorry. Okay, so 2500 is our sum of the first 50 odd numbers. So question 11 says find the sum of 40 terms in the sequence Tn equals to 3n plus 1. Okay, now this basically, guys, this gives us some sequence that whatever n is, okay, whatever term, depending on what n is going to be given by 3n plus 1. Okay, so we can find whatever term we like. We can sub in 2 to get the second term, we can sub in 6 to get the sixth term into this formula. Okay, so sometimes some questions actually do provide you with a formula or like a sequence formula in which you can find whatever term you like. Okay, but the question actually asks us to find the sum of 40 terms. Okay, so how are we going to do this? We need to find the sum of 40 terms, and we're given this Tn formula. Do you have any ideas, guys? Well, basically what I'm going to do is start off by finding term 1. Okay, I'm going to sub in 1 into this equation because I want to find the first term. Okay, usually if I find a, it's pretty helpful, isn't it? So I'm going to go and find a, the first term, by subbing in n equals to 1. So I'm going to find T1, so I sub in 1 into this n, so I have 3 times 1 plus 1, which is simply 4, isn't it? So basically our first term is 4, guys. Okay, so I found my first term. Now what do we want to do? What do you want to do, guys? Is there any ideas? Well, what I think, because it's asking us for the sum, the easiest thing I could do is find the last term, 40th term. Remember how if there's 40 terms, the 40th term is the last term, isn't it? As I said before. So I'm going to find T40, okay? So I just sub in 40 into n. So I have 3 times 40 plus 1, which is 121. And for those who are wondering why I found the first term and the last term, I can just use it in my sum formula where n divided by 2 times first number plus last number equals to the sum, right? So I've got the first term, I've got the last term, I'm just going to put it into my sum formula if we have first term and last term. So n divided by 2, a plus l. Remember this one, guys? Just put it in there, okay? It's like this. N is 40, isn't it? Because there are 40 terms. So I'm going to go 40 divided by 2 times a, okay, the first term is 4, so I put 4 there. L is 121, so I put 121 there. Okay, have a look at that. So basically I'm just putting everything into the formula. Now simplify it, you should get 2,500. Okay, 40 divided by 2 is 20, yeah? And then 121 plus 4 is 125, and then times together you should get 2,500. Okay, do you get that? That's the answer. That's the sum of 40 terms, and that was pretty easy because I could just easily find my first term, I can easily find my last term, which is term 40, and just put it all into the formula. Okay, so that's something you can, some technique you can learn if you're given a TN formula like that. Okay, so that's question 11. Have a look, and let's move on to the next question. So question 12 says the sum of the first 10 terms of an arithmetic series is 100. Okay, the first 10 terms, if we add them all up, it becomes 100. And the sum of the next 10 terms, so the 10 terms thereafter that, is going to be 300. Okay, and it's asking us to find the common difference, so it's asking us to find D. Alright? Okay, now what I'm going to do is, given that first 10 terms added all up is going to be 100. So I'm going to use that information. I'm going to say T1 plus T2 plus blah, 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 blah up to T10 equals to 100 as given. Okay, it was given like this. Remember our sum formula, n divided by 2 times 2a plus n minus 1 times d. I just put it into there. There's 10 terms, so I'm going to go 10 divided by 2. The first term, I don't know what that is, I'm just going to go 2a plus, how many terms? There's 10 terms, so I'm going to go 10 minus 1, d equals to 100. Okay, so I don't know what the first term is, I don't know what the common difference is, but I'm just going to put it like that. Simplify it, you should get something like this. Okay, so basically, 10 divided by 2 is 5. Okay, so over here, I have 5 times 2a plus 10 minus 1 is 9, so I have 9d. Okay, equals to 100. Divide both sides by 5, guys, and then this side would just be 2a plus 9d, and this side would be 100 divided by 5, which is simply 20. And I'm just going to label that as equation 1. Okay, I'm just going to leave that as equation 1 so I can refer back to it. So that's equation 1. I've built an equation in terms of a and d. Now that I've done that, I'm going to apply my next bit of information. It says the sum of the next 10 terms is 300. Okay, so the 10 terms after these 10 terms is 300. So I'm going to go like this. Term 11, okay, so because I've added up to term 10 here, term 11 plus term 12 plus blah, 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 blah plus term 20, so that 10 terms added together is going to be 300. But guys, think about this. So we're not going to apply this rule straight away again. Think about this, guys. It's like this. So term 1 up to term 10 added all together equals 100, right? Okay, that's what's given, it's 100. And then the term 11 plus term 200 is 300, right? So the next 10 terms added all together is 300. So therefore, term 1 up to term 20 is going to be 100 plus 300, which is simply 400, right? Okay, so we're going to use this bit of information. Guys, the only reason why you can't just put this into the formula is because this formula only applies when we know what the first term is. Okay? Right? But this is not the first term, this is the 11th term. So we're going to use this kind of information here. So the first term up to the 20th term is going to be 400. So now I've expanded the explanation. Instead of using the 300, I'm going to use this bit of information, that sum of 400, like this. So how many terms altogether? Term 1 to term 20, there's 20 numbers, so I'm going to go 20 divided by 2 times 2a plus 20 minus 1 times d equals to 400. Okay? Yeah? And then this becomes simplified to something like this. Okay? So basically, this part here is this part here. 20 minus 1 is 19, so 19d plus 2a. And then see how this part here is 20 divided by 2, which is 10. Okay, so we divide both sides by 10. 400 divided by 10 is simply 40. So we come up to this new equation, and that's our equation 2. Okay? Have a look at that. Okay, so now that I've got that, that's my second equation, that's my first equation. I've got two equations, I've got two unknown values, a and d, so I can solve them simultaneously. So what I'm going to do is go equation 2 minus equation 1, so that one minus that one, like this. So this is the equation 2, this is equation 1, I'm going to subtract it. And then look, 2a minus 2a cancels, doesn't it? So we're left with 19d minus 9d, which is 10d, and then 14 minus 20, which is simply 20. Okay, so we've got 10d equals to 20 left. So what's d? Divide both sides by 10, and then you get d equals to just 2, because 20 divided by 10 is 2. Yeah? So that's the answer, guys. It's always asking us to find the common difference. So you don't have to worry about going back and finding the first term. You don't have to worry about finding a, because all it's asking is to find the common difference. So d equals to 2, that's the common difference, that's the solution for question 12. Okay, have a look, guys. So this one may have been a little bit more complex, okay? This was more of a little bit of a tricky question. Okay, so have a look. This thing here is very important, okay? Please try to remember that and apply this kind of method when you get to a question that looks like this, okay? So draw a little table or draw a diagram or a list like this, okay, to help you get a better understanding. Alright, and of course, be good at your simultaneous equations, just be careful. And then get d equals to 2. Okay, and of course, don't forget the formula of the sum. Alright? Okay, let's move on to question 13. So find the sum of 20 terms of the arithmetic series whose nth term is 3n minus 1. Okay, his nth term is 3n minus 1. What does that mean, guys? It just basically means Tn, the nth term, is 3n minus 1. So like in question 12, or actually was it question 11, sorry, we have this given equation of Tn. Okay, we have Tn equals to 3n minus 1. So we can sub anything into n to find whatever term we like. Okay, so we can find the third term by subbing in n equals to 3. We can find the 100th term by subbing in n equals to 100. Okay, so I really like it when we're given something like this. But this time it asks us to find the sum of 20 terms. So what do we do here, guys? The first thing is to find the first term by subbing in n equals to 1. So basically we're looking for T1. Okay, subbing 1 into there, we have 3 times 1 minus 1. Okay, so that's equal to 2, because 3 minus 1 is 2. So basically, guys, the first term is 2, and that's the A, okay, the A that we're looking for. Okay, guys, I hope most of you can say, now what we're going to do, we're going to look for the last term, which is the 20th term. Okay, remember with the sum formula, if we have our first term and we have the last term, it's pretty easy. So, see how there's 20 terms? So if there's 20 terms, the 20th term is the last term. Alright, so I'm going to look for T20, the last term, sub 20 into here. So I have 3 times 20 minus 1. 3 times 20 is 60, minus 1 is 59. So the last term is basically 59. Okay? Now all we need to do is apply our sum rule, the n divided by 2 times a plus l. But we're looking for the sum of 20. So I'm going to have n as 20, so s20. So we have 20 over 2. First term is 2, last term is 59. So I'm putting them all into the formula. Okay? Simplify, guys. 20 divided by 2 is 10. 59 plus 2 is 61. Multiply it together, you should get 610. Okay? And that's the sum of the first 20 terms of this arithmetic series. Okay, that's basically it, guys. Have a look. Hope that was very similar to one of those previous questions that we did. Okay, all we did was find the first term, last term, and put it into our first term, last term formula. Okay, so I hope you're getting the hang of this as well. That's question 13. Let's move on. Okay, question 14 says, how many terms of the series 23 plus 19 plus 15 plus 11 plus blah 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 must be added to give a sum of 50? Okay, so alright, they want to have a sum of 50, don't they? So how many terms do we have to have the sum as 50? Okay, how are we going to do that? Well, I'm going to start off by saying that the first term is 23. A is going to be 23 because the first one on the list is 23. Okay, so therefore I can just say that straight away. And think about the common difference. What's the difference between 23 and 19? What's the difference between 19 and 15? Okay, see how the difference? We're subtracting 4, okay? We're subtracting 4 from 23 to get 19. We're subtracting 4 from 19 to get to 15. We're subtracting 4 from 15 to get to 11. Oh, sorry, that was meant to be 4. But because we're subtracting, we have to put minus, don't we? Because we're subtracting. So therefore the common difference is -4. Okay, see how we're decreasing in value each time? The values are becoming smaller each time. So therefore we're subtracting 4. So the difference, the common difference is -4. Okay, so this also applies for series as well. Alright, so make sure you don't miss that negative sign for this one. Okay, alright, so we've got A, we've got D. So now what I'm going to do is put it into my sum formula just like that. Okay, our usual sum formula, n divided by 2 times 2a plus n minus 1d. Okay, so n divided by 2, 2 times a, so but a is 23, so I'm going to put 2 times 23 plus n minus 1. I don't know what n is, that's what I want to find, right? So I'm going to leave n as a pronumeral. So n minus 1 times d is -4, so I put -4 there. And it says I want it to give a sum of 50, so I'm putting 50 there. Okay, so the sum should have an outcome of 50, and we want to know for how many numbers make the sum 50. Okay, so n is still not figured out yet. Okay, we're going to figure that out, and the sum is 50, so I've made that equation. Now all we need to do is solve it. Okay, so I'm going to simplify it down to something like this. Basically, guys, what I'm going to do is simplify the inside of this one. I'll show you how we get to this point. I'll just simplify it for you. 2 times 23 is 46. Yep. Plus -4 times n is minus 4n. -1 times -4 is positive 4. Okay. And then simplify it. 46 plus 4 is 50 minus 4n, right? And then we're multiplying and divided by 2, aren't we? Yeah? So that's equal to 50. Now multiply everything by 2, okay? So I have n, 50 minus 4n equals to 100, sorry, because 50 times 2 is 100, and then expand out your n. Okay, so I'm going to get 50n minus 4n squared equals to 100. And because I think 2 is a common factor for everything, so I'm going to divide out everything by 2. So this one I have 25n minus 2n squared equals to 50, because 100 divided by 2 is 50. Okay, so I have this left. Rearrange it, guys. I'm probably going to move everything onto the right hand side, so I make my n squared coefficient of it positive. So if I move this over, I'll get positive 2n squared. If I move this over, I'll get negative 25n plus 50. That's what I have there, and make sure that's equal to 0. Okay, so that's what I have. They've simplified it, okay? So please add these steps in, okay? Don't just do everything in your head. Alright, so that's all I did to get to that point. Have a look at the solution, guys. What do we have? We have 2n squared. 2n squared minus 25n plus 50 equals to 0. That's what we have left, right? What does that look like, guys? that looks like a quadratic to me. Yeah, so I'm going to factorize it. Okay, so factorize it, guys. You probably have to use a cross method, yeah? And then you should get something like this: 2n minus 5, n minus 10 equal to 0. Okay, I just factorized it because it looks like a quadratic. And make sure if it doesn't factorize, trying to use the quadratic formula. Okay, now that we've done that, solve for n. N should be 5 on 2, which is just 2.5 as a decimal. And n should be 10, right? So I've got two values. But guys, don't stop there. Look at your answers, okay? Look at your answers. What's the question asking us? It says how many terms? Can we have 2.5 terms? Okay, it's like saying how many people can we have in a classroom? We can't have 2.5 people, right? It's a similar kind of thing. We can't have 2.5 people, okay? N must be a whole number basically, okay? Because the number of terms must be a whole number. So we're going to reject that number. We're not going to include that decimal number. We're only going to include the whole number, 10, okay? So the number of terms is 10. That's the only solution for this one. Just as soon as you see a decimal for these kind of questions, but make sure you read the question. In this case, it's asking for how many terms. Number of terms must be a whole number. So as soon as we see a decimal, just reject it or eliminate it, basically. Okay, so in this series, there are 10 terms that make a sum of 50. Okay, and that's the answer to question 14. All right.